Today we're talking about ratios, and I needed a table, and Fetch said we could borrow his place. That was very nice. Do you know what a ratio is? A ratio is a math word, and that math word means a comparison of two quantities. That just means I'm going to compare two things. Easy. Let's start with comparing the letters on Fetch's wall. Let's see, it says sketch with Fetch. If you didn't realize it, he's a bit of an artist. He said he might teach me how to draw later because, you know, math teacher, not an art teacher for a reason. Anyway, let's take a look at these letters. How many letters are there total? Yeah, there's 15. There are 15 total. That's my whole. I'm going to write this down over here, but we're going to talk about it in a minute. Now we're going to compare. Let's see. How many of these letters are black? Yep. 1, 2, 3, 4. I have 4 black letters. We can write a ratio of how many black letters to total letters like this. The part, the black ones, is 4. It is 4 to 15. For every 4 black letters, there are 15 total letters. That's a ratio. The neat thing about ratios, though, is it's not just compared to the whole. I can compare part to part. For example, I could compare how many black letters to how many light blue letters. How many of the light blue letters are there? 1, 2, 3, 4, 5, 6. Oh, so my part to whole, my blue to black, we said 6 blue, I remember. And how many black are there? 4, good job. We can say there are 6 light blue letters for every 4 black letters, 6 to 4. That's all a ratio is. It's taking one quantity and comparing it to another. We could do it like with these dots up here too. Let's see. How many yellow dots do you see? I see 1. Can you see that one over there? You might not be able to see it. There's 2 over there. How many blue dots do we see? Here's 1, 2, 3, 4, 5, 6. Oh, so we've got like 2 to 6 for the dots. This is a pretty cool place to talk about ratios. So ratios are really neat. And another thing that's kind of cool is we have 3 different ways we can write them. If I want to write my ratios of 4 black letters to 6 blue letters, I can write it 3 different ways. And you need to know all 3 because they want you to know all 3. Okay, the first one is just 6 to 4. I'm literally just writing the word to, T-O, not the number, the word. You see that here, 6 to 4. That is the ratio of black letters to blue letters is 6 to 4. Okay, a really, really common way to write ratios is with a colon. If you don't remember what a colon is, it's where we have the 2 dots right here, one on top of the other. And this we read the same way. When we're speaking it, we say the same thing. We say 6 to 4. The last way we can write it, which we're going to use it a lot in math, is like a fraction. We have the 6 on top, we have our little fraction bar, and then we have a 4. And we say 6 to 4. We are going to be doing a lot with fractions. We did a lot with fractions, as you remember. And why do we do that? Because we use them so much, especially in ratios. Let's talk about how we can use ratios when we're cooking. You know, since Fetch has let us use his table here, I thought we were going to make him some trail mix. So I brought some things together to make some. There's some nuts, some chocolate chips, and some banana chips. Don't laugh, that's all I'm putting in. I'm a teacher, I don't earn that much. This is what's on the shelf, right? All right, so how are we going to do this? Well, we're going to check our ratios. When we make one batch, we're kind of making this up together. Let's start with 1 scoop of nuts. So we're going to get a scoop of nuts. Close enough. And I really like banana chips. I think we're going to go with 2 scoops of banana chips. There's 1. Yeah, we need 2. There's 2. But what's trail mix without chocolate? How about a half a scoop of chocolate chips? All right. I'm going to mix that up. That's a lot of banana chips, just the way I like it. So there we have our trail mix that we're going to make. Let's talk about the ratios in this trail mix. We said, I'm going to write it down. We put in 1 scoop of nuts, 2 scoops of bananas, and a half a scoop of chocolate chips. Remember? We did that together, right? I'm going to scoot this closer so I can write on it. Well, what if Fetch tells me he has a whole bunch of friends coming over and he needs more trail mix than that? He wants, let's say, twice as much. Let's get that out of the way. Let's say Fetch needs twice as much. Well, that's okay. I can just change the ratio of each one. If I have 1 cup of nuts and he needs twice as much, so now I need 2 cups of nuts. Let's see if I can write left-handed. Okay, if we have 2 of bananas, we said 1 times 2 is 2. If I have 2 cups of bananas, how many bananas am I going to need now? How many scoops, excuse me? I'm going to multiply that by 2, right? 2 times 2, we're going to get 4 scoops of bananas. Nice. Well, what about this 1/2? If we multiply that by 2? Right, we're going to have just 1 full scoop. So do you see how the ratios, I can put any numbers I want in it as long as I'm consistent. If you're one of my students, you've heard me say many times, math is the only thing in your life that's totally fair. I can do whatever I want as long as I do it everywhere. So for example, if I double the nuts, I have to double the bananas, and I'm going to double the chocolate chips. So now the ratio is staying exactly the same. Does that make sense? So recently at my school, we had a school dance, and it was like a beach party, and I was wearing this very bright orange and yellow flower aloha kind of shirt, and it was great fun. And I had a former student ask me what color shirt I was going to wear, and I told her it was going to be orange and yellow and stuff. Well, she made me a bracelet. Wasn't that really nice? I was wondering how many beads there were in this bracelet, so I counted them, and for my 1 bracelet, there are 31 beads. My ratio is 1 bracelet to 31 beads. Well, I thought, I wonder how many beads she needs if she wants to make 2 bracelets. Ratios are really useful in life. So this we can figure out. Well, if I'm going to say 1 times 2 is 2, I want 2 bracelets. How many beads am I going to need? Right, we're just going to multiply it by 2. We'll wind up with 62 beads. Makes sense, right? Well, what if we go with 3? 1 times 3. We're going to get 3 bracelets. Well, what's 31 times 3? Yeah, it is 93. I did not know that I could write left-handed and upside down. I hope you were as impressed as I am. Anyway, charts like this are a really nice way to write out ratios. We're going to do more with these in a later video, but I wanted to show you that we can compare our bracelets and our beads. We can write the ratio of 1 bracelet to 31 beads. Pretty cool, eh? Thank you for joining me today to talk about ratios. Since we already had a hello and I'm glad you're here. Did I ever say that? Hello, I'm really glad you're here. Now I have to have my equal ratio because it's 1 to 1. I have to say goodbye. Thank you for joining me here at More Math. By the way, you know, the ratio of 1 to 1 for every like we get a subscriber, that's pretty great too. Have a great evening.